This is a story about Eratosthenes of the Alexandria Library around the year 200 BCE. And the story goes like this. Eratosthenes worked at the Alexandria Library in Alexandria, Egypt, and he had an interest in maps. In fact, Eratosthenes is sometimes considered the founder of the science of geography, the mapping or the graphing of the world. So here's the deal. One day Eratosthenes read a report about shadows in the town of Syene. And according to the report, in the town of Syene, which is south of Alexandria along the Nile River, in the town of Syene at midday on the first day of summer, vertical objects cast no shadows. And also, according to the report, that if you look down a water well, a deep water well, you could see the sun's reflection. So this was puzzling to Eratosthenes because in order for those phenomena to occur, no shadows and vertical and the sun visible in water wells, the sun would have to be directly overhead. That is 90 degrees above all horizons. And that was puzzling to Eratosthenes because that wasn't the case in Alexandria. So, for example, Eratosthenes would go out at midday on the first day of summer and would see shadows. So, for example, here he is looking to the south, and you can see that the walls are casting shadows to the north. And then over here, the south-facing wall is fully illuminated, but the north-facing walls are in shadow. They're in shade. You can also see that here with this palm tree. Okay. The palm tree is a vertical object, and it's casting a shadow actually to the north. Let's take a look over here at this column. So I'm going to stand on the south side of this column and look up. And I can see that the south side of the column is fully illuminated, and you can see the sun in the southern sky. But now if I go to the north side of this column, it's in shade and I can't see the sun. That would put the sun, again, in the southern sky. And you can also see here that obviously this column is casting a shadow to the north. So this is a problem for Eratosthenes because these observations are inconsistent with the prevailing flat world model. The flat world model, according to the flat world model, the vertical objects in Syene or Alexandria, they should be casting the same kinds of shadows. So in other words, according to the flat world model, as shadows are cast to the north in Alexandria at midday on the first day of summer, they also should be cast to the north in Syene at midday on the first day of summer. But the report argues that they're not. So let's take a look at another thing. So the report also indicated that if you look down a water well, you could see the sun's reflection. And we can't see the sun's reflection there. If we dive into the well and take a look up, you ought to be able to see the sun. But in the town of Syene, apparently, according to the report, we would be able to see the sun, but we can't see the sun here. So this, again, continues to be a puzzling report for Eratosthenes. Here's another trick you can do. You can take a stick and lean it up against a short wall like this, and making sure that the bottom of the stick touches the edge of the shadow of the wall. And if you measure that angle turns out to be about 7 degrees. So that's a simple trick for determining the angular location of the sun. In this case, the sun is about 7 degrees in the southern sky. All right, so all of this information caused Eratosthenes to wonder that according to the report, let me put it this way. There are two possible things that this could mean. Number one, that the report was wrong, and number two, that the flat world model was wrong. So what Eratosthenes did to test this, he hired a fellow to travel to the town of Syene and to estimate the distance between Alexandria and Syene, and also to verify the claim that vertical objects cast no shadow at midday on the first day of summer. The fellow hired by Eratosthenes to travel to Syene determined or estimated that the distance between Alexandria and Syene was about 500 miles. He also was sent here to test the claim made in the report that Eratosthenes read. Test the claim about the lack of shadows cast by vertical objects. So here in the town of Syene, we're in the town of Syene, at midday on the first day of summer, you can see that vertical objects are not casting shadows. So if we look, we're on the southern side of this column. We can look up directly, we can see the sun. Now we're on the northern side of this column. We can look up and we can see the sun, and there definitely is no shadow. If we go to the water well, take a look, we can see reflection of the sun in this wavy water. We go into the water well and take a look up. We can clearly see there is the sun up there. So it's pretty evident that in the town of Syene, at midday on the first day of summer, vertical objects cast no shadow. And that is information that Eratosthenes can use because he has an idea of what this might mean. So the fellow that Eratosthenes had sent down to Syene reported back and reported two important findings. Number one, that vertical objects in fact do not cast shadows in the town of Syene at midday on the first day of summer. And that's different from the case in Alexandria. And number two, that the distance between Alexandria and Syene was about 500 miles. So just to review, the prevailing model of the world at the time was the flat world model. So according to the flat world model, shadows in Syene and Alexandria should be roughly the same. Vertical objects should cast shadows roughly the same in both cities. But the report and the confirmation of the report argues otherwise, shows otherwise, which means that to Eratosthenes, perhaps the flat world model is not an accurate representation and maybe not an accurate characterization of how the world actually is. So he proposed an alternative model. He proposed a spherical world model. And according to this model, the cities of Alexandria and Syene are separated on this curved surface. And we know that the angle of separation, we established this before with the little stick and the shadow on the wall, the angular separation is about 7 degrees. So here's the deal. 7 degrees is about 1/50th of a full circle being 360 degrees. So now we know that Alexandria and Syene are separated on this sphere by about 7 degrees. And we also know that their linear separation, the distance between them, is about 500 miles. So that would mean that 500 miles is about 1/50th of the way around the whole planet. So this becomes very simple. You take 500 miles times 50, and you get 25,000 miles, which is the circumference of the Earth. So with sticks and shadows, Eratosthenes accomplished or contributed two main contributions. One, that the best model, more accurate model of the Earth is a spherical world model, and two, that the circumference of the world we live on is 25,000 miles. So this is, in my view, the most elegant scientific investigation ever done, because it is so remarkably simple and the findings are so remarkably powerful.